Alright, we're going to finish up where I left off on this last problem, which what I was talking about the slope of the tangent lines for the right hand side of this graph, and I had talked about how it was really steep and then less and less steep, so that's why we came up with that curve. Now on this side we have a really not very steep tangent line, so at -4 maybe it's 1/8, then at -3 maybe it's 1/4, then maybe it's 1/2, and at -1 it's just getting closer and closer and more steep. So as you can see, if I was to draw tangent lines to the curve, they would get more and more steep. They would still never cross over that asymptote, and remember that asymptote occurred because of the tangent line to the curve right there is a vertical tangent line. The last example I want to talk about, the first question it asked me is to determine the speed of the ball bearing after t seconds. Now I want you guys to notice that you might think that there is some sort of product rule that's going to take place or whatever because this is a variable. But what we're going to be doing is putting constants in for each one of those. So we're just actually testing each one of the different speeds at a particular time. So we are not actually going to be using a product rule on this. We're just going to take the derivative, which gives me the velocity. That's 9.8 sine theta t. The speed of it is always the absolute value. So I've answered part A. Part B just asks you to complete the table and determine the value of theta that will produce that maximum speed at a particular time. So we don't even care how long we're going the speed or for how many seconds it's going to happen. We just want to know where the maximum speed occurs. When theta is what? So when theta is what sort of constant? What you're going to want is you're going to want your graphing calculator. You're going to want to be able to look at the table. That would be much easier to fill in this table with your graphing calculator. So if you don't have your graphing calculator, pause this, grab it, and then come back. You should have your graphing calculator by now. And what you're going to want to do is you're going to want to hit graph, the y equals button, and you're going to put in for y equals what s prime of t is. Remember, s prime of t is your velocity. So you're going to type in 9.8 sine x. Don't worry about the t. We're going to have t's in all our answers for our table. What we're going to do is we're going to ask the calculator at each one of these values, what is s prime of t? When I put in 0, I do get 0. I am missing that number. When I put in pi over 4, I get 6.92 t. When I put in pi over 3, and all I'm doing is asking my calculator each one of these things, I get 8.49 t. When I put in pi over 2, I get 9.8 t. When I put in 2 pi divided by 3, I get 8.49 t. And what you will find is this pattern where it's coming back down. So what we can determine from this table is that when or if theta is equal to pi over 2, the speed is the maximum. You can also, because it's increasing and then it starts decreasing, so it is a maximum. It's increasing and then it's decreasing.